This project is finally over. Oh my god. I forget what this section's called. 7.2a. I think this is 7.2a. Or 7.3a. Anyway, we are going to be covering a very special unit that is honestly not that complicated. When I first heard about it, I was like, what is this? This sounds like it sucks. But it's actually simple. You really only need to know two equations. Here we go. The section is called volume by disk method. And I think there's one really good illustration that is gonna give, like, kind of set a precedent for what this whole unit is about. So, okay, most of this is review, and these are just stupid little pictures I just drew, but this is a circle, and if the line is drawn right here, and the circle is rotated around like this, pretend that's better, you're gonna get a sphere. Let's say that we want to find the volume of this sphere. What's going to be the best way to do that? I think we should cut it up into little slices and take the measurements of those individual slices. And that's like the baby way of teaching you how to take an integral. Now, by this point, you should know how to take an integral. This is a specific integral formula to figure out the volume of shapes when revolved around either a line like this or a line like this. There's like two separate things we're going to cover today. Rotations seem complicated, but they're actually fun. Yay! Here's a kind of example of what this unit is going to be all about. So if you're given a function like this one, y equals square root of x, it looks like this. This is like what we're going to want to find in this unit. We want to find volume of solid created by revolving this function around the x-axis. We all remember this is the x-axis. Later on, we're going to be revolving around the y-axis, but for right now, we just want to find, for this particular problem, that going around the x-axis. It's going to give you a shape that cooks, what? That's so silly. That looks something like this. Oh my god, this is literally so awful. Oh my god, it's so terrible. Why can't I draw? That looks something like this. So you can see that this function, when rotated like this around the axis, is going to create a shape like this. And to find the volume of this shape, we're given a lit equation. I'm going to put it right here. This is the equation we're going to be using for a problem where we are revolving this function around the x-axis. Let's plug in our r of x. I just use r of x just because. Remember, our function is y equals square root of x. So there we go. Wait a second. Remember what I said in the beginning about the sphere and how we find the volume of it is like cutting into tiny little pieces? Well, this is the equation if we want to measure one of those tiny little pieces or one of those tiny little discs. Wink, wink. Remember the name of our unit? Do you see like the little discs that we make if we cut it? This is like a disc right here. I don't know if my art skills are that good, but that's why it's called the disk method. We're not gonna like sit around and count up an infinity number of that. That's why we have that silly little integral. Ooh. You take pi out of the equation. Like pi isn't in the integral. So this is the equation, but we can't forget this because right now we're taking the integral of God knows what. So on this particular equation, let's just say this goes to 4 and this is obviously 0, from 0 to 4. And this is your equation. We all know how to solve an integral here. This is a really, really simple equation because it's our first one. So you can do this by hand or in your head, but if you throw it into a calculator, you're gonna get 5.33 pi.
Yeah, that's wrong. 8 is 8 pi. That was like something you could do in your head. I don't know why I used a calculator and did it wrong. If you're gonna plug it into a calculator, make sure you do it correctly.
Then you got your answer. You can find an exact answer, but this one's pretty good for me. I'm happy with it.
I shouldn't have been happy with it. Like, it's wrong.
My marker's kind of dying. Sorry, Miss Broderick. Ooh. This is really important. These are the ones you're gonna need to know. I'll wait for you to take a screenshot. done. So we already covered this in our first little fun example. This one's honestly like the pretty easy one. Once you get the gist and the hang of this equation, it's pretty simple. But rotation about the y-axis is what we need to cover next because there's a couple more steps, or it's like it's a bit hard to perform. As you can see, it's f of y squared and dy, so it's all with respect to the y-axis, obviously, because that's what we're rotating around. So let's do a problem with that. Here's another example of a revolving around the x-axis problem, because I thought it was a y one, and then I wrote it down, and it took a really long time to write down, so now I'm not going to erase it. I might as well just like do it again. Determine the volume of a solid formed by revolving the region bounded by the graph f of x equals x squared. The x-axis and 0 is less than or equal to x is less than or equal to 2 about the x-axis. It's going to look like this, okay? And it's going to be revolved about the x-axis. These are our regions bounded, right? So there we go. This is what we're looking for. But it's revolved, so it's going to look like this. So guys, what are we going to do? Pretty obvious, if you ask me. Remember that fun little equation I taught you? Volume equals, sorry if I'm standing weird. There's a desk. Volume equals pi integral. What are our boundaries? That's right. From 0 to 2. And then we put our function. Plug this into your calculator using that little integral button, and you're gonna get, I got 6.4, tag the pi onto it, 6.4 pi shall be our answer. That's the volume of this. Now I'm finally gonna show you one that's a little more tricky, one that's related to y-axis revolving is so fun. All right, here we go. Y equals 4 minus x squared. And this equation is bounded by the x and y axes. I don't know how to spell axes, so I just wrote axis. In quadrant 1 and revolved about the y-axis. This is when the alarm better sound in your head. Pump the brakes here. We have a revolving about the y-axis. Remember to always look at which axis it's revolving around, because that's going to change everything. The problem is find the volume of the solid formed. I don't know about you guys, but I need a graph. Oof, I need one bad for this problem, because we got to get a visual image of what they're asking for. So let's do one. This is what the equation looks like. Now we need to revolve it around the y-axis. No, the y-axis. And then there's gonna be like a little circle down here. You guys have all seen shapes. We have our regions bounded, boom, boom, boom. Where'd it go? Let's do some math now. Let's go back to our original equation during one of these type of problems. It's gonna be volume equals pi times the integral from a to b of f of y squared dy. If you look at each part of this, it kind of breaks down to the volume of a cylinder. So this is gonna be pi. This is our radius. And this is gonna be the height of our disc. So you guys can maybe try to kind of see how the function itself is the radius, because it's gonna be like this. So hopefully that gives you a better image and why we need to change the equation to fit something that revolves around a y-axis. So what is our radius? Sadly, we can't just say y equals 4 minus x squared is our radius. No, it has to be with respect to x. So we need to rewrite this as x equals the square root of 4 minus y. That is going to be our radius plug-in. So since we have this, we can start putting it into our equation. Volume equals pi integral of square root of 4 minus y squared dy. But what do we put here? See, in problems like this where it doesn't really give you any boundaries, and it just says it's bounded by the x and y axis, you can draw a graph. That can be really helpful, or find out where it intersects both of these to find your boundaries. Here we can see is from 0 to 4. We have all our parts. We have all the parts we need. Yay! Again, the last step is pretty easy because we've already covered integrals in past chapters. If it's during a calculator part of an exam, just plug it into your calculator. That's what I've been doing. So I'm gonna go do that right now. Volume equals 8 pi. This one honestly can actually be done pretty easily in your head because the square cancels out the square root, and so you can just simply solve by doing a simple integral. So, okay, last thing, I wanted to do a problem that has like a couple more steps because those first two were kind of simple. This is one that you probably get more often because it involves like a little bit more algebra and calculus, and it combines more than just one unit. So the problem is find the volume of a solid generated by revolving the region bounded by graphs of equations about the line y equals 4. Y equals 4, the line is horizontal, so it's easier, what we're used to. Enter your equations, y equals x squared and y equals 4. You're going to graph both of those. So we got the graph of y equals 4 and the graph of y equals x squared. It's important with these types of equations when we're talking boundaries and volume that you know where they intersect, and you can do that by setting them equal to each other. And here is -2 and 2. That becomes important later. We need to figure out what function we're plugging into this equation, so we need to find the combined function almost, and that's r of x. And to do that, you're going to take the top function minus the bottom function. When graphing comes in really handy. If you can't graph, just plug in a point and whichever one's higher, that's your 1. So in this case, it's going to be 4 minus x squared. We're going to plug it into this, which we've done like 4 times now. And we're going to get volume equals pi times integral from -2 of 4 minus x squared dx. And we're going to get 34.13 pi. When you get to this type of complicated math, you can usually use your calculator with integrals. Okay, awesome. Okay, that's everything. The disk method, I thought it was really hard when we first learned it in class, but then I realized it's literally 2 equations, and kind of once you get those 2 equations down, you can use other knowledge from different calculus sections to figure out what you're trying to solve for, if that makes sense. Finally done with these videos. I loved making them. You guys got this. Hopefully this video wasn't a letdown. Honestly, my videos kind of went like this. My bad. That's on me. Love you guys. Math is fun. Don't forget it. Love calculus so much. Bye.